So the last strategy that we're going to look at is sometimes you're not able to count all of your permutations all at once, and you have to break them up into separate cases. So one of them would be counting number questions like this one. How many numbers of at most 3 digits could be formed using the digits 0 through 9? Okay, and since we're using the digits 0 through 9, we're imagining the sort of listed, we can just add to this one. I'll be more clear on quizzes. We're not going to repeat. We're going to imagine we have 0 through 9, we have one of each, and we're not going to repeat them. So I'll be clear on quizzes and tests for that. Now, why is it that we have to do cases here? Well, if we just did 3 spaces, that would only count 3-digit numbers. And we can't include 0 to begin with, because then it will be a 2-digit number. But if we use 0 to begin with, it would tell us we're not allowed to repeat it later. And 90 is a number that would be allowed. So what we do in a cases question is first we recognize that we can't count it all at once. So we break it up into pieces that we can count. And once we've counted each of those pieces, we just add them up in the end. So for case 1 here, case 1, we're going to count our 3-digit. And for cases question, that this is your little explanation. You write case number 1, 3-digit. You can do your spaces. Do we have any restrictions on our 3-digit numbers? Can't be 0 to start. So that's a restriction. And if it's not 0 here, we would have 9 choices. Now we could throw 0 back in, 9 choices, and then we've used up 2 numbers, so now there's only 8 choices left. 648 in total. Okay? Case 2. What haven't we counted? 2-digit numbers. There's 10 digits, but you have to start off with not being 0. Because if you started with a 0, you wouldn't make a 3-digit number. It would just be a 2-digit number. Because 025 is just 25. So now if I was doing a 2-digit number, do we have any restrictions? Yes. Not 0 again. And there would be 9 here and 9 here for 81 in total. Case 3 is our 1-digit. Is 0 a number? Yeah. Yeah? Okay. So then there would be 10 choices there. I think 0 is a number. I got it on a test once, so. And then what do we do with each of these cases? Since we counted them separately, add them all up, and we would get 739. 739 different numbers are possible. So with cases questions, you have to be able to recognize that you can't count something all at once. And often what will give you a hint that you can't count it all at once is that there are 2 restrictions on your numbers. And by trying to do both restrictions at the same time, it becomes impossible. So here's an example. We want 3-digit numbers. We're only using 1, 2, 3, 4, and 5. No repetition. They need to be greater than 300 and even. So when we go and do our spaces and we have a restriction, we deal with our restriction first. But we have two restrictions. Here, our first digit is a 3, a 4, or a 5, and our last digit is a 2 or a 4. So where's the problem? Well, if I say I have 3 choices here, how many choices do I have for my last space? 1 or 2. It's a problem that I can't put a number in there because sometimes it'll be 1 when I choose the 4, and other times it'll be 2 if I chose the 3 or the 5. And even if I dealt with the last restriction first, let's say, oh, well, maybe it'll work better if I put a 2 in here first. Now, how many choices do I have here? I'm going to have either 2 or 3 choices. The problem is that we have an overlap in our restrictions. So that the way that we deal with that overlap is we break it up into cases. If I knew my last digit was a 4, that would tell me for sure what I need for my first digits. If I knew my last digit was a 2, that would tell me for sure what I need to do for my first one. You get to choose for your cases. You can either break up the last restriction or the first restriction. So let's start by breaking up the last one. Last digit is a 2. I would still have 3 spaces, but now I'm saying for sure that my last digit is a 2. I only have 1 choice there. Now my other restriction, that my first digit has to be a 3, 4, or 5, how many choices do I have for that? It can be any one of those, so I have 3 choices for that. There's no restrictions on my middle number, but I've used up my 2 and 1 other number for my first digit. How many choices are left for my middle digit? There's still 3 left, because just because there's 3, 4, or 5 here means you only use up 1 of them. Say you pick the 5. The 3 and the 4 can still go back into the middle and be counted there along with the 1 that's left. So there would be 3 choices left there. Multiply those together. There are 9 numbers that end with the digit 2. Case 2, what haven't we counted yet? If it ends in a 4. Now for my first digit, it can only be a 3 or a 5. That is a nice squiggle bracket. So if there's a 4 here, there's 1 choice. Now my first digit, there's only 2 choices. How many are left for our last space? 3 digits still left for 6 in total. Have I counted up all the cases? Yes. Because I wanted to make sure my last digit was a 2, and I counted all the ones that ended with 2. I wanted to count all the digits that ended in 4. And so now there was 9 that ended in 2, 6 that ended in 4. Gives me 15 in total. So before we were counting numbers in the millions very, very quickly, and now it took us quite some time just to count to 15 because it had to be broken up into cases. This is not the only way this one could be broken up. Some people like to break it up with the first one. They do case 1, start with 3, case 2, start with a 4, case 3, start with a 5. That would be fine. It'll add up to 15 as well. Some people would say, well, I could do the first digit, case 1, start with a 3 or 5, because that won't overlap with my last one. If I started with a 3 or a 5, can you see that my spaces would look like this? 2 for 3 or 5. This one would be 2 or 4, and there'd be 3 left, which would give me 12. What haven't I counted? Starting with a 4. If this is a 4, that has to be a 1. This one then has to be a 2, it would be a 1. and there'd be 3 numbers left, which would be 3. Add them up, you'd get 15. So no matter how you break up your cases, the numbers will differ while you're doing it, but adding them up in the end will come out to the same number. So you have some choice with that. For part B now, we need it to be greater than 232. Okay? This one doesn't have to be even. Part A was greater than 300 and even. Part B is just greater than 232. Why is this one problematic? Well, can you see that, could the first number be a 2? Yes. Are there restrictions on the second number? Sometimes. Right? There's a restriction on the second number if it's a 3, 4, if it's a 2, but not if it's a 3, 4, or 5. So this is where it gets problematic when you try to do it all at once. So as soon as you run into a problem with trying to do it all at once, break it up into cases. What I like to do with these ones that are greater than is I like to start with my case 1 is the easiest one. What could I put as my first number so I wouldn't have to worry about any other restrictions? Well, if I started with the 3, 4, or the 5, because it's the 2 that causes problems, then the rest of the numbers are easy to figure out. If I start with a 3, 4, 5, that decision there would be 3 choices. Now I've used up one of the 5 numbers, but doesn't matter what's next, because if I start with 3, 4, or 5, I'm guaranteed to be bigger than 232. So now I have 4 numbers left, then 3 numbers for 36 possible ways. Case 2, I'm going to start with a 2. Yeah. It doesn't have to be even. Even was just for A. So case 2, if I start with a 2, I still have some restrictions on my second one, right? Because it could be a 3, but then that'll restrict what I can do with the last one. So again, if I start with a 2, what would I guarantee that would make it bigger? Make it a 4 or 5 next, because all my numbers in my 240s and 250s will be bigger than 232. So I'm starting with a 2, only one choice there. Then I'm saying 4 or 5, 2 choices there. And now there would be no restrictions on my last number. There's 3 numbers left for 6 possible ways. What haven't I counted? My numbers in the 230s. So that'll be my case 3. So I'm going to start with 2, then 3. One choice there, one choice here. What are the numbers that are possible for the end to be bigger than 232? 4 and 5. And this is why it's important to write numbers underneath, because if you just try to do it in your head, you might include 3, because 3 is bigger than a 2. But the problem is we've already used up the 3. So the only possibilities left are 4 and 5 for 2 ways. Add them all up, and we get 44 ways in total. Yes?
Since these are word problems, we have to say there are 44 ways.
Yeah.
Whatever.
Yeah. Okay, so I'm going to give you a handout. The nice thing about this handout is all of the strategies are mixed up together. So you have to read each question and figure it out. This is a unit where you get better at it by just practice, because you start to group questions together and start to recognize things, but that comes with just reading more and more questions and getting used to them. So I'll hand that out for you.